All right, let's go ahead and take a look at number 4. It says the graph shows the distance a monarch butterfly travels over time. Tell whether the graph shows a constant or variable rate of change. Then we're supposed to find how fast the butterfly is traveling here. Okay, so take a look at your graph. Do you see the rate of change being different between any set of points? The correct answer is no, you don't. Why? Because it's a line. No matter where I calculate the slope between, no matter which 2 points I calculate the slope between, the slope is always going to be the same. Here's proof. Here's another point that happens to be on that line. Right? And we'll come down here to where we're talking about the slope, and then I'll come to talk up here about what we saw in the beginning. Again, the slope is how much something changes this way first versus how much something changes that way second. So if we go with what they're actually doing here, which is what you can see here in the bottom, to go from the point in black to the other point in black, the first thing we have to go is 2 jumps up. Now you might be saying, well, wait a minute, that doesn't say 2 there. Realize that this axis here is going by 20s. So the first jump is 20, and the second jump is another 20, which actually puts me up to 40. And that is what you see here. Then I figure out how much I go to the right here. Well, I'm going to make 2 jumps to the right, and since that's going by 1s, that is a legitimate 2. So the slope of the line shown here is 40 over 2, which of course reduces to 20 over 1. Slope here, since we're talking about the rate of change, slope is how much it changes this way versus how much it changes this way. We're talking about how much the distance is changing versus how much the time is changing, which is what they're talking about here. But let's go back to my original point here where we're talking about finding the slope a different way. Let's say I go from this point to this point. If I start here and try to get here, the first thing I'm going to do is 1 jump up. All right, well, again, this is going by 20, so 1 jump up is the same as increasing by 20. Then I'm going to make 1 jump to the right. Again, this is going by 1, so that's actually just 1. Well, what does 20 over 1 reduce to? 20 over 1 reduces to just 20. Well, that's curious because the slope we found there just a second ago with different points said 20. No, it's not really all that curious, actually. Why? Because it's the same line. No matter which 2 points I try and find the slope between, when I figure it out, as long as I do it correctly, that answer is always going to be, for this particular line, 20. All right, and since it's always 20, all right, that means it's constant because that slope is going to be the same no matter where I calculate it between. It's not changing. All right, so number 1 here, tell whether the slope is positive or negative and then find the slope. All right, so this line points down from left to right, so hopefully you're yelling at the screen right now, negative, negative, negative. That's good. All right, anytime the line points down from left to right, the slope is negative. Then I have to find the slope. The slope is how much something changes in terms of its y values versus how much something it changes in terms of its x values. Now, given these 2 points, we've got a lot of counting to do, but that's not a big deal. Start with the rise. The rise here is going to take me down, so that's going to be a negative result. So to go from this point to this point, I'm going to have to go 1, 2, 3, 4, 5, 6, 7, 8 jumps down. So my rise here is going to be negative 8. Again, anytime I go down, it's going to be negative. Up is always going to be positive. Then I've got to figure out my run. My run is how much I go to the right to get to that point. Well, in this particular problem, I go 1, 2 jumps to the right. So my run here is 2. So the slope here of that line is negative 8 over 2, or the fraction that reduces down to negative 4 over 1. And again, as I said in the introduction, realize that I said the slope was negative, and this answer was also negative. It has to be that way. If I'm saying the slope is positive, that numeric result should also end up being positive.